You're about to see opera houses that look 100 years ahead of their time. Imagine walking into a building where the walls curve in ways that shouldn't be possible, where titanium shells span distances that defy logic, where every surface is calculated to perfection. China built 14 of these architectural impossibilities, and the engineering behind them will make you question what you thought was buildable. Let's start with the structure that rewrote every rule. National Center for the Performing Arts. Picture a titanium and glass dome rising from an artificial lake, 212 meters across, and you enter it underwater. You walk through a tunnel beneath the lake and emerge inside a shell with no visible columns, thousands of tons floating on hidden steel. Inside sit 3 separate concert halls with complete acoustic isolation. 18,000 titanium panels, each curved differently, interlocking like scales. Concrete pilings, waterproof membranes, constant pumps keeping it watertight in the lake. Once that dome sealed, there was no going back. But this was only the start. Guangzhou Opera House. Imagine 2 boulders carved by a river, frozen in steel and granite. 75,000 granite panels, each one unique, covering twin structures that curve in impossible directions. Steel frameworks cantilevered at angles that shouldn't work. Concrete poured into custom formwork, rebuilt for every curved section. Inside, a double-skin facade. The outer granite handles structure. The inner skin controls sound. The main hall seats 1,800, carved from geometry that required new construction techniques. Cantilevers pushing out with nothing visible holding them up. But the engineering was about to get even more extreme. Harbin Opera House. A building designed for -40-degree winters where the walls flow like frozen wind. The foundation challenge. Pilings driven deep past the frost line into ground that freezes and thaws. Aluminum panels flowing seamlessly across the surface, each one precision cut because a millimeter off breaks the flow. Inside, solid wood curves shaped to guide sound. 1,600 seats in geometry with no parallel walls. Built on wetland soil, accounting for settling, freezing, thawing, and shifting. Construction in sub-zero temperatures with materials that don't forgive mistakes. But the next one brought a different structural challenge. Shanghai Grand Theater. A glass arc intersecting a perfect square, 2 geometries forced into one structure. The arc curves 60 meters, with supports thin enough to disappear. Where glass meets solid, steel frames transfer loads between straight and curved. Inside, an acoustic shell that changes shape variable panels, adapting the hall for different performances. Steel trusses spanning the entire building. Foundation pilings driven deep into Shanghai's soft soil to prevent settlement that would crack that glass wall. Precision in shapes that fight each other. But precision was about to be pushed even further. Jiangsu Grand Theater. Picture forms cantilevering out at angles that seem to ignore gravity. The structural framework is pure engineering defiance. Steel trusses hidden inside sculptural concrete, transferring massive loads back through paths that twist and turn. Every angle calculated to keep tons of material suspended in space. The facade wraps the geometry in glass and metal panels, each one fitted to curves that change across the surface. Inside, acoustic chambers, carved from volumes that refuse straight lines. The foundation system anchors cantilevers that push the limits of what steel can hold. They built shapes that look impossible and made them stand. But the complexity was about to multiply. Shanghai Oriental Art Center. 5 petal pavilions, each one a separate steel structure, connected at a single point. Here is the engineering challenge. Making 5 independent buildings share loads while maintaining acoustic isolation between them. Steel frameworks rising from a central core, branching out to support glass and metal petals that curve in different directions. Each petal houses a different performance space, concert hall, opera hall, theater, all requiring their own acoustic treatment. Sound isolation between petals achieved through structural gaps and dampening connections. The curved roofs span without interior columns. Glass walls wrapping the petals, supported by steel frames hidden in the geometry. 5 buildings functioning as one, engineered to never interfere with each other. And the structural audacity kept escalating. Suzhou Bay Grand Theater. A structure rising from water, where foundation engineering becomes everything. Pile systems driven deep into the lakebed, supporting a curved concrete shell that spans the performance spaces. The shell isn't just structure, it's acoustic shaping, exterior form, and load distribution all in one continuous surface. Glass facades integrated into curves, waterproofing details engineered to handle constant moisture. Inside, acoustic surfaces treating sound in volumes wrapped by that flowing concrete. The construction sequence: build the foundation in water, form the concrete shell in sections, seal it watertight, then carve the interiors. They engineered permanence into unstable ground. But island construction brought even harsher challenges. Zhuhai Grand Theater. 2 shells rising from an island, inspired by ocean forms, built in marine conditions. The foundation engineering. Pilings driven through tidal zone into stable bedrock, resisting saltwater corrosion and wave action. Concrete shells forming double curves, structural geometry that required custom formwork for every section. Glass facades wrapping the spaces between shells, sealed against typhoon winds and salt spray. Interior acoustic chambers isolated within the curved forms. Wood surfaces shaped to control sound in spaces with no flat walls. Construction on an island meant every material came by water. Every pour timed with weather. Every seal tested against ocean moisture. They built permanent architecture in conditions designed to destroy buildings. And the petal geometry was about to return with more complexity. Changsha Meixihu Grand Theater. 3 petals of flowing concrete, each one curving in directions that defy traditional formwork. Zaha Hadid's parametric design required computer modeling for every surface. Custom formwork built, used once, then rebuilt for the next section. Steel frameworks inside the concrete, following curves calculated to distribute loads through geometry with no right angles. Glass integrated into the flowing forms, structural supports hidden in the petal edges. Inside, 2 performance halls wrapped by those curved shells, acoustic treatment applied to surfaces that constantly change angle. The foundation anchors petals that reach out over the plaza, cantilevered on steel and concrete that twists as it transfers load. They poured liquid concrete into shapes that looked like sculpture and made them structural. But there were still 5 more, pushing different limits. Wuxi Grand Theater, a wing-shaped form rising from the waterfront, engineered for dramatic cantilever. The structure has steel trusses forming the wing's skeleton, concrete shell wrapping the framework. The cantilever extends over the water, counterbalanced by mass anchored deep in the foundation. Every ton calculated to keep the wing from tipping. Facade panels are glass and metal fitted to the curved surface. Inside, acoustic chambers shaped by the wing geometry. Wood panels angled to control sound in spaces that taper and flow. Foundation pilings driven into waterfront soil, resisting lateral loads from wind hitting that massive cantilevered form. They built a wing that doesn't fly, but stays suspended over water through pure structural calculation. And the riverside challenges kept coming. Chongqing Grand Theater. 3 separate volumes cantilevering over the Yangtze River, connected by glass bridges. Here is the foundation challenge. Building on a riverside slope where soil stability changes with water levels. Pilings anchored into bedrock beneath the shifting ground, supporting structures that reach out over the water's edge. Steel frameworks form the cantilevers, massive trusses transferring loads back through the connected volumes to the anchored core. Glass and metal facades wrap the geometry, sealed against river moisture and fog. Inside, performance spaces carved from volumes that step down the slope. Acoustic isolation between halls achieved through structural separation. The glass bridges connect circulation but kill sound transmission. They engineered 3 buildings to act as one, while the river constantly tries to undermine the foundation. But more theaters were still coming. Nanjing Polygrand Theater, a sculptural form where curved glass meets angular concrete in sharp geometric contrast. The structural system has steel frames supporting glass surfaces that curve in one direction, while concrete volumes angle in another. Where they intersect, complex connection details transfer loads between materials with different structural properties. Interior volumes shaped by the competing geometries, acoustic surfaces applied to walls that shift from curves to angles, performance spaces fitting into forms designed for visual drama, not acoustic convenience. Foundation systems distributing loads from asymmetric geometry, preventing differential settlement that would crack the glass to concrete connections. They forced opposing geometries to work together structurally. And the architectural ambition wasn't slowing down. Hangzhou Grand Theater, a crystalline form of folded glass planes and angular steel reflecting Westlake's water. The structure has a steel framework forming sharp angles, supporting glass panels that meet at precise vertices. Each connection point engineered to handle loads coming from multiple directions as the folded planes push against each other. Inside, acoustic chambers wrapped by those angular surfaces, sound control achieved through precisely angled reflectors rather than curves. Performance spaces carved from geometry, that's all edges and intersections. Foundation anchoring asymmetric loads, the folded form, creating uneven weight distribution that required calculated counterbalancing. They built precision into sharp angles, where tolerances measured in millimeters. One more remained. Polygrand Theater Shanghai, a twisted form where the entire structure rotates as it rises. Here is the engineering challenge. Steel columns following spiral paths, each one angled differently to support floors that don't stack vertically. Load transfer calculations running through geometry that turns on itself. Glass and metal facade panels, each one unique because the twist means no two sections repeat. Inside, performance spaces fitting into volumes that rotate acoustic treatment on walls that spiral upward. Foundation resisting torsional forces, the twist trying to rotate the entire building on its base. Pilings driven deep, anchored against rotational loads that traditional buildings never generate. They built a structure that defies the fundamental principle of vertical construction. And now you've seen all 14.